Alright, so welcome back guys. Now probably good news for most people in that this will actually be the final lesson covering the syllabus content. So far of course we've covered variables, constants, if statements, so selection, right, case, iteration, records, I guess arrays. Basically we've covered everything except just this one thing, right? So classes, so specifically object-oriented programming. Now, if you're doing IG or if you're in AS, then this is actually not required. Okay, this is only for A2, and even for A2, this might be in paper 3 where part of the theory paper they sometimes give you small extracts of code, and they might say sort of fill in the blank, or just write a couple of lines of code sort of defining a class or declaring a class. However, for paper 4, this shouldn't really be included, because paper 4 is going to be the real programming language. Now the only thing they might have is they might give you some pseudocode of a class and then ask you to write that in Java, Python or VB.NET, right, whatever language you or your school has chosen. With that said, hopefully we can just go through this quite quickly, right? It should be sort of a shorter video than some of the others, even though there is a lot of content here regarding OOP. Now I will just quickly kind of explain all of these OOP concepts, although the idea is really that hopefully you would have already been taught this in your school classes. This should just be a quick little recap. So I'm just going to zoom in a bit just so we can read this. So in this video, obviously we'll cover classes, right, object-oriented programming, and I think I'm going to change the order. So we'll talk about attributes. So attributes, basically there'll be a variable that's part of a class, right? So we can say a class variable basically, right? That's called an attribute. There's also going to be methods, so that's going to be a class function or class procedure. So a class module. Now this is called encapsulation, where we have both the attributes and methods as part of one object, or as part of one class. Now in contrast, we've looked at records before. So records, we can group data, right? We can group variables or attributes. So if we have, let's say, a person record, they can have, let's say, a name, an age, a gender, right? Things like that. So with a record, we can group attributes. However, we can't actually add methods, right? So functions, procedures to records. However, with classes, right, that's going to be the difference. That a class can also have methods, right, as well as attributes. We'll also talk about public and private. So public, this means we can access these attributes, these methods from outside the class, whereas private means we can only access them from inside the class. And this has the advantage of let's say security, and not so much security from hackers, for example, but more security in terms of let's say you or other programmers not mistakenly kind of changing values. If it's private, then we can access things via a getter and setter, and then if we have a setter method, right, then we can add validation. Again, we'll look at this during the class. We'll also look at constructors. So a constructor, that's going to be the default method that's called when we create an instance of this class. What this means, when we create an instance, let's say we create a person class, the class is just the template, right? So creating the person class won't actually create anything we can really use. We actually have to create an instance of a person. So we can go like person 1, person 2, person 3, right, creating 3 instances of people. When we do that, again, it's going to call the constructor. That's going to be the default method, and here we can let's say assign the initial values, for example. We'll then look at inheritance. So let's say again, if we're using a person class, maybe the person has name, age, gender, but then we could have maybe a class of, let's say, student and teacher, which can inherit from this. And what that means is, it means student and teacher, they're going to have all of the same attributes and all of the same methods as person has. So yeah, they'll have access to, those attributes, those methods. But then we can also add additional ones. So for example, let's say a student, well, maybe they could have, a list of subjects that they study, or for example, like a list of grades. Whereas in contrast, a teacher, well, they could have, a list of subjects that they teach, or maybe sort of, a list of classes that they teach. And yeah, they can also have their own methods as well. So maybe a student could have a method like take test, whereas a teacher could have a method, for example, mark test. Now, sometimes we might have it where, let's say we might have a method like maybe print information, or maybe output information. Now, we might have that method in both the parent class, right, so the base class or super class, right, and also in the child class or inheriting class. So what we can do is, well, we can use the super keyword to specify that we want to access the super classes, and when we say super, right, that just means the parent class. So yeah, if we use super, well, we can specify, right, we're using the parent class's method rather than the child class's method that has the same name. And then we can also do polymorphism. So if we break this down, well, poly, this just means many. Morph, this just means sort of change shape or change form. So let's say, for example, we could have some method like swim. And if here we're looking at Pokemon, so this swim method could be in the Pokemon class. And let's say this could print, say this Pokemon like can swim. Right, but then there might be some Pokemon that can't swim. So in that case, what we can do is sort of in the inheriting class, we could then, let's say, override this swim method to print out, I don't know, yeah, like unfortunately this Pokemon can't swim or something. Yeah, just some error message basically. So yeah, maybe that's not the best definition. But basically polymorphism just means, well, we can override the behavior, say in the parent class, and yeah, in the child class we can give it different behavior. Alright, so here we're actually only going to try one example. Now if this is not enough, and if this still doesn't make sense, well, again, of course, yeah, ask in the comments, also ask your teacher. But you can also come down here, let's see if I can find it. Yeah, we can see here, right, OOP, object-oriented programming, and of course, here we cover everything as well, and specifically, we've got sort of two kind of quite detailed examples here, right, with a school and then also shapes. But yeah, since there is a lot here, we're only going to cover one example today. Right, so just quickly then, the example we're going to cover, well, it's going to be Pokemon, and if you're not familiar with Pokemon, well, right, each Pokemon, it's like a little animal basically. And they're going to have a name, they're going to have an icon, right, so just like an emoji like this. Right, also they're going to have health, and I think we'll say health will start at 100, and then if it reaches 0, well, they're going to faint. So faint, basically, that's Pokemon's version of dying basically. Yeah, they're also going to have a type, so we see here, right, the fire type and then water type. Now, this will be easily extensible because, the real game might have like 20 different types. But yeah, we're only going to do 2 just to keep it simple. And yeah, like I said, did faint. So this basically specifies, if they're sort of living or if they're, if they're, unconscious, if they fainted. Right, we're also going to create relevant getters and setters. So a getter to, basically get the values of these attributes. Then setters, well, to, update or change the value of these attributes. In terms of the game mechanics, well, each, let's say a Pokemon can attack other Pokemon. Right, the amount of damage they inflict, this will depend on both types of Pokemon. And I think here I've actually just made a little document. So let's say here, if we say the attacking Pokemon is fire, right, and then this fire Pokemon is attacking another fire Pokemon, well then the damage modifier is going to be 1, right, so it just does, the default damage. However, if we have fire attacking water, right, well that's not going to be very effective. It's only going to do 50% damage. If we have, water attacking fire, well that's going to do double damage. And yeah, water versus water, right, that's going to be 1. And I mean, I've just got it where, you know, the same type attacking the same type, that's just going to be 1, right? So along this diagonal here. And I mean, if we think about this, I mean, if we're using a real programming language, you know, we could implement this using dictionaries, and we would probably want, you know, a dictionary of dictionaries. Or let's say if you're using Java, well, that's going to be hash maps. So yeah, like let's say a hash map of hash maps. However, I mean, hopefully we can see, well, here this is just a table. And now if you have a table, then you have to think, well, 2D array. Okay, so we can represent this using a 2D array. And yeah, we'll also see how we can map, you know, these sort of string types to the actual, you know, sort of row and column position, right, the index positions. Yeah, let me maximize again. And I mean, here we said again, well, if their health reaches 0, they faint, and Pokemon that faint, well, basically they're kind of just disabled, right? They can't do anything. So yeah, hopefully this makes sense. And I guess with all that said, I mean, let's just go ahead and get started. So yeah, let me just move that down a little bit. So I think first then we can just create those attack modifiers. So we said, you know, fire versus fire, that's going to be 1. And what we want to do, we want to think, well, how can we actually get the specific index position? So if we say, you know, say Pokemon A is fire, and then Pokemon B is water, well, that should be, let's say, row 1, column 2. Right, now the way we can actually do that is if we set the types as being an enum, because we can say, you know, fire has the value 1, right, water, well, that's going to have the value 2. And then, yeah, we can use that to actually get the index positions. So yeah, let's just create that array first. So, all right, let's go declare. And let's call this maybe attack modifiers. And then here, let's go, right, this is going to be an array. Right, let's say 1 to 2 and yeah, 1 to 2, because again we've got basically, well, 2 rows, you know, fire and water, and again 2 columns, right, fire and water. So yeah, just a simple 2 by 2 array. And then I think here we saw this is going to be real. Okay, sorry, that should be of. And yeah, this is going to be of type real because, well, we had 0.5. Right, and then I'm just going to actually assign these values. So let's say here, and we'll just assign it quickly, right, just on one line. So I think fire versus fire, that's 1, right, this is going to be 0.5. And then we said, right, water versus fire is going to be 2. And yeah, water versus water, right, that's just 1. Right, I think then I said, well, then we just want to create an enum. So if you remember how to do that, we can just go type. Let's call this Pokemon type. And let's go, that's going to be fire and then water. Alright, so hopefully you can remember the syntax of this. And let's just demonstrate this works. So let's try to get the value. Let's say here, so this is going to be what, water, or so water attacking fire. So if I just output, and let's say attack modifiers, right, this will then be Pokemon type dot water. And we say, right, this water is then attacking a fire Pokemon. Right, and then this should just output 2. So let's check. And yeah, okay, we see, so this works. So I think in terms of, you know, say the global variables, or let's say the, yeah, I suppose kind of user defined type, right, that's what Cambridge would call it. Yeah, so, you know, in terms of the global and user defined types, right, that's all we really need. So now we can actually go on just to actually, you know, making the classes. So in order to make a class, well, we use the class keyword, right? Then we say the name. So yeah, I'm going to call that Pokemon. And then here we just go end class, right? Just like, you know, function, end function, right? Class, end class. And now what I'm going to do, we can actually look here at the attributes. So one of the attributes is name. Now, if this was just a normal variable, well, we would say, let's say declare name and of type string. However, we shouldn't actually use declare here inside a class, right? We need to actually specify the, I mean, let's say the access level or the sort of visibility. So basically, you know, public or private. Now here, let's just go public, just to demonstrate what this does. And I think, I mean, well, let's see if that works. It might give us an error. Okay, I mean, that seems to work. However, I mean, really what we need, we actually need the constructor. So the constructor, well, this has to be public, right? Because we have to access it from outside the class here. Right, this also has to be a procedure, and then we also have to call it new. And then here, let's just go end procedure. Right, so a constructor, you just have to remember these three. Now, if you're familiar, let's say with Python, so I think Python, the constructor is just going to be the init method, and I think the init also has self, right? Then it has the list of parameters. Now, if you're doing Java, you would go class, right, and then you say the class name. You go public, right, and then you go the class name Pokemon like this. And I guess then here you'd also have the parameters, right? So this would be the constructor in Java. As for VB.NET, or I'm not sure how that would be. But yeah, I mean, so hopefully you're familiar with constructors, right? Hopefully you've done this, in your own language. Right, so what's going to happen then? This will be called when we create an instance of this Pokemon. So let's just demonstrate this, and let's go output, and we'll just go created, and let's say created Pokemon. All right, yeah, if I can spell that. Right, then in order to create, the thing that's maybe a little bit strange, we actually don't need declare or anything. We can just directly give it the name. So I'm going to say Charmander, and then here we just go new, right, and then we say the actual kind of class name that we want to create an instance of. All right, so here when we say new, well, this is just going to create a new instance of this Pokemon class, and then as this is being created, this is going to automatically call the constructor. All right, so if we just run this, and yeah, here we see, well, created Pokemon, okay, because this constructor is always automatically called. Now, of course, this works, but yeah, and well, for example, let's just demonstrate this. We can also give the attribute a default value. So let's say Charmander like this. And then rather than saying Pokemon, well, let's actually go and name. So yeah, this should just say created Charmander. And yeah, of course, we see that. However, the problem with this, well, if we just copy this Pokemon, copy, this instantiation. Let's now change this to Squirtle. And if you're not familiar, well, Charmander, this is just a fire Pokemon, right? Squirtle, that's going to be a water Pokemon. I think maybe from the original game. Now, the problem with this is, well, here they both say created Charmander because we've given it this value and we've never updated it. So I think what I'm going to do, I'm going to delete that, and what we can actually do, well, we can pass this as a parameter. So for example, if we just go here, right, let's say Charmander. And then let's say here, right, this will be Squirtle. And then, yeah, because, well, these parameters will be passed here into the constructor. So I'm just going to say name, and that's going to be type string. And then what I can do, basically I can just go name and then assign to name. Now, this is actually slightly wrong, and I mean, we'll see what happens here. So it's going to say the following ambiguous attribute and parameter names were detected, right, name. So when it says ambiguous attribute, well, that means, right, this attribute here, and then parameter name, well, that's, yeah, this name here. So I mean, basically what that's saying is, well, this attribute and this parameter, they have the same name. So for example, when we say, right, this name, well, does that mean this name, or does it mean this parameter, right? There's obviously no way to distinguish. Now, again, let's say, well, if you're using Java, right, I mean, Java, you would go sort of this.name to kind of specify that you're using the class attribute. Likewise, Python, right, you would use self. However, in Pseudocode, we don't have that. So I think really, the easiest way to do it, well, I just use this kind of convention of saying p name. So p, this just means parameter, right? So yeah, let's just assign that. So we're saying, well, this parameter name is going to be assigned to the class attribute name here, and then yeah, here then we're just going to sort of output the class attribute name. So this should say, well, create Charmander, then create Squirtle, and yeah, okay, so that this works. So actually, let's just have a look at this. Maybe I'm just going to comment this one because we don't really need it. Now, because this is public, you actually notice we can just go output, let's go Charmander, and then go name. And if we look at this, well, we see here we've got this green dot. and this green dot just means it's a public attribute. All right, whereas I guess here, well, let's change it to private. I mean, hopefully that's updated. And yeah, so now since it's private, all right, we can see it's like an orange or red. But I mean, let's just undo, right? Let's go back to public here, and then I mean, this should just output. Yeah, so you can see we can directly access this attribute. Now, not only can we sort of get it, right, we can also set it. So if we go charmander.name, and let's just call this like Squirtle. So obviously here, this is kind of a mistake really. And then let's just output it again. And yeah, so here we see, this kind of correctly changes it. Now, I mean, I think in the real Pokemon game, you can change the name because, well, you can give them a nickname, right, a kind of alias. But let's say, for example, the health, right? So yeah, the health specifically. Well, here we would probably want some kind of validation because we would want to check, well, the health should never go negative. And also the health should never go, bigger than 100, right, greater than 100. So yeah, to kind of limit that, we can just have some if statements, add some validation. And then, I mean, that validation would have to go inside the setters, which I guess we'll kind of look at later. So yeah, I mean, this is kind of one reason why you don't really want to use public attributes, because public attributes, well, you're not going to be able to add sort of validation like this, right? Someone can sort of, accidentally modify them. Now, in contrast, let's say if we make this private, and I think currently this is not the best error message. But yeah, basically it says, well, line 38, right, that's this one, cannot read properties of undefined. I mean, honestly, like, I'll probably try to, improve the error message at some point. I try to, add a detection for this error, try to improve it. But I mean, basically the reason for that is because, well, this name is private. So when we do charmander.name, well, this name is going to be undefined, right? Because basically we can't access this from outside. So yeah, right, in order to actually access that, well, let's go ahead and create the getter. So here we're going to say public, and then because we want to get the value, then this means we have to actually return it. So that means it's going to be a function, and let's just call it getName. And I mean, here we don't need any parameters, right? And then we're just going to say returns, and because it's name, well, name is a string, so let's just return string. Yeah, I'm just going to end function here. And then if we go inside, right, this is pretty simple. We literally just return name. And again, I think if I just show you, well, we can see here, right, orange. So that means, yeah, this is a private variable, or I guess, well, private attribute. So in order to access that, well, now we can go get name. And notice how, well, this get name has to be public, because if get name was private, then we wouldn't be able to access this getter. All right. So this is what Cambridge says. And I guess, a lot of sort of OOP, I don't want to say rules, but let's say recommendations. The recommendation usually is that, attributes generally, they should be private. Whereas, of course, getters and setters, I mean, well, usually they're going to have to be public. Because yeah, you're probably going to want to access them, from outside the class. But yeah, I mean, Cambridge, I mean, basically they say attributes should always be private, unless they specifically tell you to make it public. But I mean, yeah, let's also just change this one. And I guess, okay, well, let's also add the setter, because otherwise this is not going to work. So in order to add the setter, well, again, it has to be public. Right, this time it's going to be a procedure, because we don't need to return anything. Right, let's call it set name. And then because here we're going to update the name, well, this is going to also need a parameter. And just like here, let's call it p name, just to kind of differentiate the parameter in the actual class variable. And then what we can do, well, we can just say name, just like we did in the constructor. Yeah, just name and then assign that the value of p name. And let's go end procedure, just like this. Right, and then what we can do here, let's go set name, and right, just add the bracket, and then yeah, the closing bracket here. So I think this one should just work. And yeah, okay, we can see, so right, first we get the name, So we're just going to output Charmander, right? Then we set it to Squirtle, and of course, yeah, then again we get this. Right, but I think I'm actually just going to delete these because, yeah, we don't really need them, to be honest. That was just to demonstrate. So I think what I might do, I might just go ahead and just add these. So yeah, just add these remaining attributes. So let's go private, and yeah, I mean, okay, let's just go icon. Like, honestly, the order doesn't really matter, but I guess maybe you just want to order them from, you know, most important to least important or something. But I mean, yeah, let's go health. And I mean, we could say health could be real, but I think I'm going to keep it a bit more simple, and let's say, yeah, health can only be integer. Right, if we then go type, so the type here, this is going to be, well, the Pokemon type, right, so just this enum. And then, right, okay, did faint. So did faint, that's just going to be a boolean, true or false for, you know, yeah, if they're fainted or not. Right, now here is where, you know, we sort of need to use some logic, really. So we need to think, well, what values are going to be the same for every Pokemon? And if they're the same, well, we can just directly assign them inside the constructor here, versus, you know, what values are going to be different for each Pokemon. So if we think, well, icon, right, this is going to be different because, you know, here we've got, right, the fire icon, the water icon. Whereas if we look at the health, well, if we look at the rules here, okay, health always starts at 100. So for that reason, it makes sense we can just, you know, directly assign that here inside the constructor. Because, for example, let's say we did something like this. Let's go p health and let's say integer. Now, let's say here we assign it, you know, 100, right? That's going to be correct. But, you know, maybe, I don't know, maybe like 100 lines later or in a different file. Yeah, or perhaps by, you know, a different person. Like, let's say if they accidentally assign this to be 0 or, you know, maybe 20, for example. You know, then, of course, well, we've got code that's inconsistent because, yeah, this Pokemon's starting at 100, right? This is starting at 20. So in order to keep things more consistent, well, if the value is always going to be the same, right, then it's better, you know, not to have it as a parameter. And of course, yeah, we can just directly assign it here like this. So let's say that's going to be 100. But yeah, let's look at the icon, right, because the icon will change. And let's say this is going to be char. Right, the type, this can also change because, again, you know, this is fire, this is water, right, so yeah, that's going to vary. And that's going to be Pokemon type. Right, I'm just going to move this across a little bit. And then, right, okay, I think did faint, well, this should also start. And that should be false, right, because obviously it's going to be sort of, yeah, like active, basically. Right, and well, then we just need to assign them. So let's go icon, and that could be p icon. And then we'll go, right, then we go type, and let's assign that the value p type. So, right, I think this should work. And let's maybe also create a method just to output the information. So, right, let's think here. I mean, this has to be public because, again, we're accessing from outside. Right, it can be a procedure, I guess, because, yeah, we can just have an output statement. So let's say maybe output. I know, yeah, just output info. I guess that's probably fine. Right, let's go end procedure. And then what we can do is we can output something like this, right? So Charmander has 100 health remaining, right? It is a type 1 Pokemon. And yeah, probably we also want, you know, sort of the faint status as well. So right, let's just try and output. Okay, output. So here, let's just go name, right? And then we'll say has, and let's say, yeah, then, in fact, all right, let's also go the icon as well. Okay, so yeah, this should be like, say, the fire icon, then a space, right, then name, then let's say has, and we'll then say health, let's say health remaining, or you know, we could just say HP, right, so kind of health points. Right, let's say maybe its, yeah, I know its type is, and then we'll just go type, and then we can say maybe and its faint status is, and then yeah, this is just going to be, well, did faint, so true or false. And right, let me just try and fix this. Okay, there we go. Yeah, again, I'm not really sure why that happens, where sometimes if it, wraps onto a new line, basically the whole code editor just kind of shifts left. But I think usually just sort of forcing the window to resize can kind of fix it basically. Right, okay, so I think, yeah, that should work. And let's just try this. So let's go Charmander, and then we'll just go output info. And then I think here actually, because this is a procedure, well, let's see if it gives us a warning. Okay, right, I also need to change this. So let's just copy, let's copy the fire icon, and then the next one is type. So here then that can be fire, and then the type is going to be, well, Pokemon type.fire. And I mean, this might give us a warning saying we need to use call. Okay, no. But I mean, really, right, we should use call here, because if we look, right, this is going to be a procedure. And yeah, I mean, that works the same. So if we look at that, so yeah, Charmander has 100 HP, its type is 1, and its faint status is false. Alright, so I think that's working. Now here, the type, well, because this is an enum, it's going to be the actual, numeric value. Now, again, if this is a real programming language, hopefully they would have a feature that would allow you, let's say, to either output the numeric value, okay, or output a sort of string representation. Now, I know, well, I'm pretty sure that Java has that feature. Python, maybe. I mean, as for pseudocode, well, we don't have that feature. However, if we do want to do that, so for example, here we want to output, fire, right, or water, then of course we can just create an array. Let's say maybe, I don't know, yeah, Pokemon type string names or something. Right, let's say that's going to be an array, that's going to be 1 to 2, and let's say of string. And then here, let's just assign this. And what we'll then just say, right, the first one will be fire, and then the next one will be water. Because obviously, again, if we get this sort of index 1, right, that's going to be here, yeah, index 2, right, that's going to be this one. So in order to do that, let's go Pokemon type, okay. And then here the index is going to be type. So let's say maybe it's a, so we want to say, it's a fire Pokemon. And I think that should be okay. Yes, it's a fire Pokemon, and its faint status is false. And of course, well, we can choose to make this lowercase if we want, right, or keep it uppercase. Yeah, I guess it doesn't really matter. Right, so I think, I mean, yeah, for the attributes, that's fine. I mean, let's look at what we need to do. I think, I mean, okay, so I think probably let's look at inheritance now. Because if we think, right, let's say we just want to create another Charmander. Now, again, let's say Charmander 2. Well, let's say, and let's go here, maybe I'll just copy. For example, here, like, what if we accidentally use the wrong icon, right? Or if we accidentally use the wrong color, the wrong type, then of course we're going to get inconsistent data. Or yeah, we're going to have, inconsistent sort of objects, right, instances. And, you're going to have a situation where, like, Charmander attacks Charmander, but because this is water, this is going to do double damage. Yeah, even though, of course, it should just be 1, right, the default multiplier. So what we can actually do is, well, we can create another, class, right, specifically for Charmanders. And I mean, I think I also made this, in Java, in Python. And I think then what I did, well, let's say I had Pokemon. So yeah, I had Pokemon as the base class, right? Then I also went, for example, Fire Pokemon. And right here, notice this is not an assignment arrow. This is actually if you had an inheritance diagram. So here we're saying, let's say a class diagram, right? Inheritance diagram. Where here we're saying, well, Fire Pokemon, right? This means it inherits. So yeah, Fire Pokemon inherits from Pokemon. And then, for example, I'd have something like Charmander, like this. And then, of course, I'd have, Water Pokemon, Squirtle, maybe Grass Pokemon, Bulbasaur. But, you know, in this case, well, I'm just going to keep it simple, right? Let's not have that fire Pokemon. And to be honest, I'm not even sure if this website would work having, you know, multiple levels of inheritance. I've not actually tested that. So yeah, let's just keep it simple, because, I mean, honestly, the exam wouldn't require multiple levels of inheritance. I mean, yeah, certainly not for pseudocode anyway. Right, so let's say here then, we just want to create a class, and this can be called Charmander. And I'm just going to use, you know, a big letter for the class name. Right, again, let's go end class. And I mean, every class, well, again, we're just going to need the constructor. So let's go public procedure, right? Remember, we need to call it new. Right, then we say end procedure. Now, and okay, actually, let's remember we say inherits. So, right, this will inherit from Pokemon, which again, that means it's going to have access to all of these attributes, right? It's also going to have access, you know, to all of these methods right here. Now, right, I mean, let me just delete this one, and I mean, let's try and run this. Like, probably this will give us an error in here. And yeah, so what this says, well, first statement in Charmander's constructor should be a call to its parent with, well, super.new. And let's just go here, right? So that means inside here, basically. So what we can do, I mean, here, right, we can use call. However, I noticed that in the, I think in the example here, so yeah, if you go to the pseudocode guide, right, from Cambridge, I think they actually don't use call. So yeah, I mean, so basically I've made the website where it's going to work, you know, with or without call. But let's just go super.new. And I suppose technically, you know, it probably should be call, because if we look, well, right, the constructor, that's going to be a procedure, right? So yeah, I guess we should use call. But anyway, right, so here then we're just saying, well, this is going to have no parameters. But, you know, if we actually look at this, well, let's change that to Charmander. You know, I think we actually will want a parameter. All right, so I think we can probably give it the name. So let's say here, this will be p name, and let's say that's going to be string. All right, this can be p name. Now, if we think about this, so for Charmander, well, the icon is always going to be fire. Again, the type is also always going to be fire. So what we can actually do is, well, we can pass them just as parameters inside here, right? So this means we won't have the situation where, you know, well, yeah, where let's say if a developer is, you know, creating an instance of Charmander where they accidentally use the wrong icon, or they accidentally use the wrong fire. The wrong type, because, you know, obviously we're just defining it inside the class, so we're only defining it in one place, which again, you know, that helps well code consistency, right? Makes it easier to debug, also easier to change, because we only have to change it in one place, rather than if we had, you know, 100 Charmanders, we have to change it in every place. But I mean, I think that should work, because if we look here, so we see Charmander, well, this constructor just takes one parameter, all right? So yeah, we see here. And then if we look, so the super, and again, just to recap, so if we say super, well, the super class is, you know, the parent class. So when we say super.new, well, this means, you know, call the parent class, right? So the Pokemon's constructor, which of course is this one here. And we see, well, this takes, right, the name, icon, and type, right, as parameters. So yeah, I think that should work, and let's try and run this. And yeah, okay, so this seems okay. Yeah, I think that's probably all I wanted to say about inheritance, at least the basic stuff. So I think probably we can just go on and, yeah, we can probably try and create this attack method. So again, we have to think, well, where should this attack method be? Now, we could create it here in the Charmander, but the problem is, you know, then when we copy this for, you know, Squirtle, Bulbasaur, like, you know, Pikachu, right, then of course we've got like 4 different attack methods. And, you know, if we have like 1,000 different Pokemon, right, we're going to have 1,000 copies of this attack method. Now, I mean, that, you know, well, there's kind of many problems with that. One, you know, if there's a mistake, well, we need to change it in 1,000 places, right? If we want to update it, we also need to update in 1,000 places. I mean, as well as that, you can also say it's going to make the actual size of the program bigger, because, you know, we've got the same code copied and pasted over and over again. So, you know, it's kind of going to be slower to load. It's going to be, you know, bigger in RAM, all right, stuff like that. But yeah, obviously the main thing is, well, it's going to be harder to change, because we've got to change it, you know, in 1,000 different places. So that's the advantage of inheritance, where we can put things in the base class, and then of course we only need to change it, or sorry, well, the superclass, and then we only need to change it in, you know, one place, right? And then like all of the child classes, well, they're going to automatically, you know, sort of use that version. So anyway, let's say here, and I'm probably going to do this maybe above these getters and setters, because I mean, really the getters and setters, you know, they're not really that important, so I'll just put them at the bottom. Yeah, let's keep the actual main sort of logic, right, or game mechanics higher. So I think, yeah, I'm probably just going to make this a procedure. Now we could make it a function where, let's say, it will return true or false for like if the Pokemon fainted. So yeah, if they attack the Pokemon then it fainted, you know, that could return like true, for example. But I think here, yeah, let's just make it a procedure. Right, let us go attack. And again, let's just end it so we don't forget. Now if we think, now this attack, well, this is going to be the attacking Pokemon, but then we also need a parameter specifying the Pokemon that we're attacking. So let's call that enemy, for example. And this is also going to be of type Pokemon. I mean, right, specifically it's going to be, you know, Charmander or Squirtle. But the problem is we couldn't say, for example, Charmander, because if we say Charmander, well, if we want to attack Squirtle, it's then going to say, you know, parameter expected Charmander, but got Squirtle. So yeah, that's why we should use kind of the superclass as the parameter here. Right, and then, I mean, basically what we can do, let's probably create a setter just for the health, right, because we're going to want to decrement the health, or yeah, sort of reduce the health. And yeah, maybe let's also create a getter for the health as well. Yeah, I mean, like, technically we don't need a getter for the health here, because, you know, we're inside the class, so we can't directly access it. So maybe I'll just ignore that for the moment, and I guess if we need it, we can add it later. So let's say procedure, right, then this can be set health, and then inside here, let's say maybe this can be the sort of, let's say the value we want to modify by. So if it's like -20, well, that's going to reduce health by 20. But I mean, in the real Pokemon games, you can also have, you know, potions, or kind of yeah, go into the hospital or at the Pokemon Center, and you know that can also well, that can, yeah, increase the health, or, you know, reset the health to 100. So this should be able to be like positive or negative. So I think for that, then let's call this maybe change amount or something, and let's say that's just going to be an integer. And again, you know, if you want, you could make it a real, but I'm just going to keep it simple. So what we can do, well, we can just say health, and that's going to be equal to health and then plus change amount, because of course if this is -20, well, health plus -20, you know, that's going to reduce. And then what we can do, then we just have to check if it's within the range. So yeah, we said 0 to 100. Now, I mean, the easiest way to do that is, well, just do this calculation and then we can check after. So we can say, yeah, if health is, let's say, less than or equal. Yeah, okay, I mean, let's say less than or equal to 0. Because then what we can do, right, then we can go, well, 1 did faint should become true, right, because, yeah, basically they've sort of died. But let's also just set health back to 0. So yeah, this means, well, if it goes to, you know, -10, it's just going to be reset back to 0. Right, then let's go else, and inside here let's have another if. So yeah, I mean, let's go maybe if health is greater than 100. Right, and then what we can do, let's say health, and we'll just set that to 100. Right, again, just capping it at 100 there. Right, then we'll just go end if and end if. Yeah, and I think that should be okay. Now, if we think this attack, well, this also needs, yeah, this also needs, say, the amount of damage that move is going to inflict. So I think what I'm going to do, I'm going to create an attack here, and right here I just called it Inferno. So let's create a procedure called Inferno. Right, Inferno, and then I think we don't really need any parameters there. And then what this can do, right, well then we can just go call and then attack. And in fact, actually we do need a parameter, right, we need the enemy. And right, that is going to be Pokemon, right, of type Pokemon. So here again we can just pass in the enemy. And let's also give a kind of default, let's say like a default move damage. So maybe by default this can do 40, or yeah, I guess 40 is okay. And I think I also had the name as well. So let's also go Inferno like this, just so we can print this out, you know, in the actual attack method here. Because you know the idea is that, well, of course here we can have Inferno, but then we can have maybe Burn. Yeah, we can have I think Ember. That's another name. Right, so yeah, we can have, you know, many different moves, and because we're calling this attack, well, as long as we, you know, change the parameters, right, then it's still going to output the correct information. Yeah, just using, you know, these updated parameters basically. Right, so what did I create? I think I called it, right, so then we've got kind of damage and then the name. So let's call this maybe base damage. Right, that's going to be of type integer, and let's say the next one, right, that's going to be name, but I guess we can't call it name. Let's call it move name, and that's going to be string. And again, yeah, that's really annoying, to be honest. Right, that's also not fixed it. Right, okay, so yeah, now we've got the correct parameters. So let's think what we actually want to do. I think first we probably want to calculate the actual real damage. And again, the real damage will be calculated based on, well, you know, sort of R type, right, the attacking type, and also the defending, right, or the enemy type. So let's go maybe declare, and let's say, I mean, well, this could be damage, I guess. Right, that's, yeah, I mean, let's say that's going to be integer, right, we can just convert it to an integer. And then what that's going to be, if we go damage, now if again we remember we can go attack modifiers. Now the first one, well, this will be R type, and then the next one we can do enemy. And now, right, let's actually create a getter here for get type. So I'm just going to put this at the bottom again. And to be honest, I'm just going to copy this and, you know, just change them quickly. Yeah, I mean, let's put it here. That's fine. Right, so let's go get type. That's going to return a Pokemon type. Yeah, and then here let's go return type. Right, so I think that should be okay. Yeah, and then right, so this then we just want to then multiply by the base damage, because, you know, if this returns 0.5, well, 0.5 times, you know, 40, right, it's just going to be 20. Yeah, that's the real damage. So I think then what we can do, let's go call, and this will, and well, again here we don't really need call, but yeah, I guess we maybe should. Right, let's go set health, and then here the health, the amount we want to change is going to be damage. And I suppose, you know, we could make this minus and then it would work, right? Or I guess we could just, you know, let's maybe go minus damage like that. Yeah, you know, or we could sort of multiply this by, you know, -1 or something. But yeah, I think this one should be okay. Right, and then what we want to check. Yeah, I mean, let's maybe just output this, and okay, maybe let's. So if we look at the form we want, so we want the old health, and then we want the new health, because we're saying, yeah, health reduced from 100 to 80, you know, 40 to 0. So let's just go here. Let's go, and in fact, I think I can also do it here like this. Right, so this can be, let's say, old health. And I mean, new health we actually don't need, because, well, we can just use the get health function. And I think here, right, let's make sure just to convert this to an int, because, yeah, we have said this is going to be an integer. Right, so the old health, that can just be equal to, right, that's going to be the enemy get health. So wait, do I not have get health? Okay, so yeah, right, this is where I need to create this. Okay, right, and then let's just go get health. Right, this is then going to be an integer, and yeah, that's just going to return health. And right, let's make this get health. Okay, and then I think I can then just output. I'm trying to think, so right, and then probably here I'll just output the fainted, probably inside here. Yeah, so if we just go output, and then this is just going to be name, right? Because even though, for example, here we're calling this, you know, from the attacker's sort of point of view, but the problem is, okay, hang on. Right, yeah, okay, so this should be enemy set health, right, because we're setting the health of the enemy. So then if we go output name, well, this is not going to be the attacker's name, right, because, you know, we're calling it in the enemy class. So yeah, this would be the enemy's name. So then we can just go name and fainted. And I think, right, I'm also going to copy that kind of skull, yeah, the skull symbol, just to make it stand out. Right, there we go, and yeah, let's go like that, and I'm just going to give it a space. Right, and then yeah, let's actually have this output before. Right, and then what we can do, so we want to use the icon, so right, this is going to be icon, and then we say and, or then we say the name. I guess, well, let's go space then name. Right, and then we say used, and I guess here then we want the move name. Right, and then we just say on, and I mean, yeah, this one's going to have quite a lot of output, to be honest. Right, so here then we want to go the enemy, and that is going to be right, and then we go get icon, which I think we need to create. So yeah, let's just copy this one again. Right, let's go get icon, that's going to return a character, and yeah, here we're just going to return the icon. Right, so we go get icon, right, then we want, I guess again, then we want a space, and then here yeah, this is really annoying with this bug, then we just go get name like this, and then we want, right, so then we just want to say what happened to their health, so their health reduced from, and then here we're going to say old health, and then let's say 2, and then that's going to be yeah, enemy.getHealth. Now probably I've made a mistake here somewhere, so let's just test it. So alright, now I think at the moment I'm just gonna create okay, in fact, well, let's just copy this, right, let's create the Squirtle now. I think we may as well. So let's go Squirtle. Right, I'm actually just going to comment this out because, yeah, we don't want this Inferno. Right, the type is going to be water, and let's just go and copy the emoji. Right, okay, here we go, and yeah, let's just well, okay, yeah, let's just type it. So let's go Squirtle, right, that's going to be new. So here we're just creating an instance of the class, right, by calling the constructor, and I think this one takes the yeah, the name as the parameter. And let's just call this, so let's go Squirtle, right, and make sure we use the instance name, right, rather than the class name. Right, and then that's going to be output info like this. Now, right, I think I'm just going to run this, and I mean, let's see if this works. And alright, so yes, I mean, surprisingly it did. I think we got no errors. Yes, it said create a Charmander, right, 100 HP, yeah, it's a fire Pokemon, it's a water Pokemon. Yeah, so I think this seems to be the correct information. Now, what we can then do, well, let's try having it where Charmander can attack Squirtle. So let's go call. We'll then say Charmander, right, and the move is going to be Inferno. Then if we see here, okay, yeah, so this one, what, it takes the sort of parameter of, you know, the Pokemon to attack. And I mean, let's try and run that, see if it works. No. Passing classes by value as default. Yeah, okay, disabled. Right. Yeah, I mean, this error message is a bit complex, but basically what that's saying is, let's say here, well, because we don't specify, then this means it's using by value by default. Now, actually, this is not what we want, because, well, this will create a copy of that class, or let's say a copy of that instance. So then when you actually reduce the health for that instance, well, okay, right, the health for that instance will be reduced, but, you know, the actual original instance, so the original instance is, you know, this Squirtle, well, this won't be modified because, you know, it's only going to be the copy that's modified. So then if you did, you know, Squirtle output info, well, it's still going to say health is 100. So yeah, actually for this, you know, we actually want to use by ref. And then I think we also have, okay, here we go. So, right, and then here, this enemy should also be by ref. Because, you know, this means we're modifying the original, let's say, you know, the original, like, parameter, rather than a copy of this parameter. Right, so let's see if this works. Right, okay. I mean, basically that's saying that if this is by ref, then these are automatically also going to be by ref. Now, I mean, we could just change the order of these and, you know, have this by ref at the end. But, you know, we can just go by value, right? Then it means, well, this one is going to be by value. And yeah, the next one is also going to be assumed to be by value. Okay, and then, I mean, that seems to work, except this here is wrong. So what has happened there? So enemy get health. Okay, it seems, I mean, right here I do change it. Oh, okay, it's because, right, because I output this before calling this. Okay, I mean, I guess maybe I can have this if statement in the attack method, right, just have it after. Because what I don't want is, I don't want this fainted to output before, you know, before we output the attack details. So yeah, maybe let's just copy this. And then what we can do, I mean, all right, maybe let's just make another variable, call it like new health. Right, I mean, I'm just going to sort of, maybe let's just copy this down here or paste it down there. Right, and then what we can do, let's copy this. And right, then what we can do, let's just go here. And right, let's go new health, and then we'll just assign this with enemy.getHealth. So yeah, this is their health, you know, after they've been attacked. Right, and then let's copy this. And then I think what I can do, if we just paste that there, and right then we can just have an if statement. So let's go if, and we will say if new health is, I mean, honestly, we only need to check if it's equal to 0. However, I am going to check if it's, you know, let's say, yeah, less than or equal to 0. But in theory, it should never be less than 0 because, you know, we've got this condition here. But, well, I mean, I will just test it, right, make sure I've not made any, like, silly little mistake. And then, yeah, here we can just go end if. Now, right, let's try again, see if this works. And yeah, so the health reduced from 100 to 80. Let's actually increase the damage here because, you know, we're multiplying by 0.5, right, just to make it go a little bit faster. And then let's just copy this. Let's copy it maybe 2 more times. So this should go to 60, right? Then it will go to 20, and well, then it should go to 0 and say they fainted. And yeah, okay, so this is working. So right, 100 to 60, 60 to 20, 20 to 0, right? Then they faint. So yeah, that's pretty good. Now, I mean, just quickly, you know, we can add an attack for Squirtle. So let's just uncomment this. I think here I called it water gun. Right, let's say here this is going to be water gun. And I mean, notice, you know, because we've created this attack, we've created this attack, you know, in the sort of base class or the super class. You know, then it's going to be really fast because, you know, all we're doing is changing these parameters. Now, because this is, you know, the superclass, right, we could also do super.attack. However, since there's only one attack method, right, this is not ambiguous because, you know, there's no, yeah, there's no attack, in this Charmander class, right? So that means what it is, I mean, basically first it's going to look in the current class, and then if it's not in the current class, then it's going to go to sort of, let's say, the immediately inheriting class. And then, if you've got multiple levels of inheritance, basically it's just going to keep going up. So it's going to go to the inheriting class. If it can't find it in there, it's going to go to the next inheriting class. Right, can't find it there, goes to the next inheriting class. All the way up, right, to the sort of final superclass. And obviously, if it can't find it there, if we say like, attacks, well, then it's going to give us an error saying, method doesn't exist, basically. Right, but I think I'm changing the Charmander class by mistake. So let's say here, right, I mean, let's just reset this to 40. Let's say this is going to be 30. But the problem is, not the problem. But the thing is, because this is going to be multiplied by 2, right, because, water versus fire, then basically this is going to be 60, right, so this is going to be pretty effective. So, I mean, if you're familiar with Pokemon, basically it's kind of alternate moves. So Charmander can attack, but then let's say next, right, Squirtle is going to attack. And yeah, let's just copy this a few times. Right, and actually I'm just going to separate them because this is kind of, move, right, so let's say, attack 1, attack 2, attack 3. And I mean, this should work, although there might be, okay, no, that's not working. Right, attacks, that's because, yeah, there we go. Again, I mean, probably this should say, attack doesn't exist, or, well, attacks doesn't exist, so I might try and improve that error message. Right, and then here it's saying we've got the same problem, so this should be by ref. And then I think, yeah, so that seems okay, although it is strange that it says Squirtle fainted and then Squirtle fainted again. Right, so hang on, so Squirtle used Water Gun on Charmander, their health reduced from 40. So I think, okay, hang on, right, yeah, this should be the enemy name for a start. So let's go there. And, of course, I also need to check. And yeah, this was one of the things I'll do next. Basically checking that, well, if they fainted, right, then we can attack them. And likewise, if we fainted, well, then we can attack, another Pokemon. So let's say here, so that's going to be in the attack. Right, and then here, this should be the enemy name. And, originally it was name because, well, we would go, enemy.setHealth. But because we've moved this into the attack, right, this is, sort of, well, the attacker's point of view, right, it's the attacker that's calling this attack method. So then we need to go, right, enemy.getName. And then I think that should work now. Yeah, then we see Charmander fainted. Right, now, of course, here it's a bit strange. It says Charmander fainted twice. So what we can actually do, let's go, yeah, we can check if the old health, right, so the original health is sort of 0. Or we can check, yeah, we can also check if this did faint is true. So let's say here, let's go if, and we'll say if enemy, and then I think we don't have a getter for this. So maybe let's go, right, public function. I mean, this we could say maybe get did faint. Right, and then that's going to return, say, well, returns Boolean. Let's go end function, and here then we're just going to return, and that will be did faint. So, right, here we go. So let's go, right, get enemy, yeah, okay, get did faint. And then, well, if this is true, so, we can just go equals true like this. However, we can also omit that if we want. But I mean, yeah, let's keep it just to be sort of explicit. So let's go then, yeah, let's go else like this, and then here let's just go end if at the end, and right, I'm just going to indent all of this, so that's going to be inside the else. Right, then here what we can say, so let's say we want to say, for example, like, let's say Squirtle can't attack Charmander, Charmander fainted, or, yeah, I mean, what do I say here? Yeah, let's say can't attack Charmander, they already fainted. I think that's fine. or maybe Squirtle, right? So let's go name. So Squirtle can't attack, and then right, this will then be the enemy. Enemy.getName. Yeah, I mean the thing is, if I say they already fainted, is kind of is a bit ambiguous. You know, does it mean well Squirtle fainted, or does it mean they fainted? I mean, let's say yeah, the this enemy already fainted. Okay. Yeah, so I think that's okay, and then let's just test that, see if it works. And yeah, so Squirtle can't attack Charmander. This enemy already fainted. That's fine. But then this should also be disallowed because well Charmander has fainted, so it shouldn't be able to attack. So what we can then do, let's have another if statement here. Yeah, and I mean, obviously, like, see, this is the thing, right? We could do it inside here, but the problem is if we have an if statement inside here, well then we also need an if statement inside this water gun, and right inside the thousands of other moves that exist in the game. So that's why it's good, we can put it in the superclass, then we only need to check in one place. So let's say if, right, then this will be, yeah, this is our health, right, so that's just if health, or I guess we can say did faint. So if did faint is true, then let's just go, I mean, let's maybe go else here, right, and then we're going to put all of this inside the else. So let's just indent that, and then here we can just have end if, and then this one. All right, I mean, what can we say here? Let's say, yeah, something like this, right? So Charmander fainted, so can't attack Squirtle. Right, so this one then, this can be name. Let's say fainted, right? So can't attack. And then that's going to be the enemy name. Or in fact, hang on, no, sorry, this is the same. No, okay, right, yeah, that's fine. Right, so yeah, Charmander fainted, so can't attack, and then that's going to be the enemy. Enemy.getName. Right, so I think that should be okay. I mean, let's run this. Yeah, so Charmander fainted, so can't attack Squirtle, and Squirtle can't attack Charmander. Yeah, this enemy already fainted. Right, so I think that validation is working pretty well. And I think now there's only one more thing we want to do, right? So we just want to look at polymorphism. So let's see that some Pokemon can swim and some Pokemon can't. Now, again, honestly, if this was a real programming language, right, you wouldn't really do it this way. Something like Java, you could use implements. Python, I'm not really sure the best way to do it, but it's probably not going to be this way. And let's say the reason it's not going to be this way is because probably like 90% of Pokemon can't swim, so it's kind of pointless having a swim method inside the Pokemon class. Because there's also other things they can do. For example, some can swim, some can fly, some can cut down trees. I think some can push boulders. So let's say they've got like maybe 10 different sort of moves like that they can do. Then you need to have those 10 different moves inside every Pokemon class. So it's just kind of a little bit wasteful really. But I mean here let's just do it sort of keep it simple. So yeah, I'm just going to do it here, it doesn't really matter. Let's go public, and yeah, let's make this a procedure, because we just want to output something like this, if we can see. So Squirtle swam to caves, and then Charmander can't swim to caves, right? That's what that's going to say. So inside here, let's just say swim, right? This will take a location of where to swim to, and let's just say this will be a string, so maybe destination, and that's going to be a string. And let's say end procedure, and then what we can say, let's just go output, and we will say name, and I suppose if we want, we can also have the icon, so let's go icon, and then we'll just go like this, yeah, just to format it. I'm going to move the mouse, and let's say swam to, and then the destination name. Now obviously, right, this is assuming that the Pokemon can swim. However, again, not all Pokemon can swim. So this is where we can use polymorphism. And in fact, well, let's just run this just to check it works. And I think I'm just going to comment this just so we can sort of get a cleaner output, right? Just less information. So let's go call again, right? Since it's a procedure, we're going to go Charmander, let's say swim, and let's say caves. All right, let's copy this, and we will then just say Squirtle, and yeah, swim to caves. And yeah, so Charmander swam to caves, Squirtle swam to caves. Now, you know, this is correct, okay, because well, it's a water Pokemon, it can swim, right? Obviously, this is incorrect. So what we said, well, if we go back to polymorphism, well, again, poly just means many, then morph, well, this means, right, different shapes or different forms. So what this means is, I mean, basically we can sort of modify the behavior of a class, or, you know, classes can have like different behaviors, basically. So what we can do, let's go to the Charmander, right, and then, well, we just want to overwrite that swim. So, I mean, we need the same kind of like signature, right? So let's go public procedure, right, we called it swim. And again, you know, we have to use the same name in order to overwrite it. All right, this is also going to take a destination, and that's also going to be a string. Let's just go end procedure. And I think here, I'm just going to copy this. I guess I could have just copied the whole thing, really. Right, and then let's just, let's just indent this, and yeah, let's say can't swim to destination. That should be okay. And again, right, if we think about this, well, when we call, you know, Charmander.swim, well, like we said, first it is going to look in the kind of, you know, child class, right, or the actual instance, sort of the instance class. So here it sees, well, you know, in the instance class, right, we do have a swim method. So then it's just going to use that, okay, then it's going to stop. Whereas if we look at the Squirtle, well, Squirtle doesn't have a swim method, right? So then it's going to look, you know, sort of in the parent class or in the super class. And of course, yeah, then it's going to use that swim method. So if we run this now, and yeah, so we get Charmander can't swim to caves. And I think finally, just to demonstrate, sometimes you might also want to call these superclass. And you know, honestly, in this case, this will be the wrong behavior, but just to demonstrate. And again, you know, we can use call if we want. So let's go super, and this will be swim, and then let's say to destination. And you know what this is going to say? It's going to say, well, Charmander can't swim to caves, right? Then it will say, you know, Charmander can swim to caves, because here using super, we're specifying, well, you know, don't use this swim, right? Use swim in the actual like kind of base class, basically. Well, yeah, in the super class. And yeah, okay, there we go. All right, so let me just check that I've covered everything. So yeah, we've looked at constructors. So again, well, if we just recap, that's going to be the default method that's called, you know, when we create an instance of the class. And yeah, well, to create an instance of a class, you know, we need the new keyword. Likewise, constructors, you know, they have to be, well, public procedure new. Right, so a class can have attributes, right, basically variables, also methods, right, so functions, procedures. Of course, yeah, they can be public, so that means we can access them from outside the class, or they can be private, which means we can only access them from inside the class. We can also use inheritance, which means, well, let's say a class that's inheriting is also going to have access to the superclass's attributes and methods. And yeah, we can specify, you know, using the super keyword to kind of call the base class's methods if we have a method with the same name sort of in the child class. And then yeah, we can also use polymorphism basically to overwrite, let's say to overwrite these superclasses methods. Yeah, I mean also attributes as well, right? We can, you know, sort of overwrite the attributes, yeah, in the actual sort of inheriting classes. Right, guys, so I think, I mean, that's everything for OOP. Now, again, you know, if you're confused, well, you know, obviously, yeah, again, you can look at these examples, you can leave a comment, I guess, yeah, ask your teacher, yeah, maybe send me a message here or just on the site, yeah, whatever. Now, probably after this, I'll make some videos, maybe just, for example, going over some of the exam papers, possibly also, you know, going over some of these challenge answers. Now, I mean, you know, these videos, they might start to get a few more views, you know, as they get older or as it comes to exam periods. So if anyone does have any specific requests, again, yeah, just well, sort of leave a comment, send me a message, yeah, whatever, and then yeah, hopefully I can, you know, yeah, try to sort of fulfill those requests. All right, so yeah, again, thanks for watching, and I'll see you in the next video.